So I hope my screen is visible to everyone. Is it visible?
Yes, sir.
Okay. In if you face any queries or if you want to ask, just unmute yourself and ask because it's impossible for me to access the chat box during session. So it's better that you should unmute and you can ask directly. Okay. So basically, you have gone through the schematic editor, the HIL SCADA, but not through the test ID. The test ID has been scheduled for the means test ID, and this. If you click on additional tools, so you'll find the waveform generator, signal analyzer, script editor, etc. So these two tools, which is script editor and Typhoon test ID, the use of it in Typhoon HIL is going to be discussed on I think on week 5, yes, week 5 regarding that control system and AI development using Typhoon HIL. So in that week, we are going to discuss about that part. And already you have seen the schematic editor that we use schematic editor for developing our models using the library components, which are available over there. So just a moment. So next we have this HIL SCADA. So after compiling the model, it is being loaded onto HIL SCADA where we just uh, take some widgets, provide the values, and we can change the parameters during runtime. So that's why it is being named as a SCADA, like supervisory control and data acquisition type of thing. Okay. Also, we can send out data through data logger purpose. Okay, using some kind of communication protocol. So that's it regarding these two tools. So today we are going to discuss about waveform generator. Okay. So you need to just click on these additional tools and then you will find this option waveform generator over here. You click onto it, let it get open. Okay, so it will open like this. Basically, as the name suggests, waveform generator. That means we can generate, means manually we can generate by giving values some kind of waveform. Either it can be PV or it can become some kind of source. Okay, so that's why if you click on waveform generator, you will get two tabs over here. One is this PV file generator, and the other one is source file generator. So you can know that the PV file generator means we can generate any PV curve or PV file using this option. And if we want to generate any source file of our own, then we can use this source file generator. Okay. So right now we'll discuss about this first tab, which is PV file generator. So in PV file generator, what you first see is here you can find new and here you can find save kind of thing. Next, you will find this option generate PV. Okay. And if you click onto it, there are two options are there, generate PV and import IV. Okay. So if we click on generate PV, then we'll find these options like select model like detailed EN50530 compatible normalized IV. And using detailed, you will get these options like you need to provide VOC, IC data, number of cells, type of cells, identity factor, or and do you want to allow negative current or not? So all the settings you need to do, and then you need to provide irradiation and temperature, and after that you can click on preview. Okay. So after clicking on preview, you can see this PV curve has been generated over here. You can see the IV characteristics and PV characteristics, and here you can see the maximum power, current, and voltage over it. And now you can save this file using this option. Okay, if you click onto it, here you can save this file by giving a name and just a moment. And here you can see the panel type is saved as .ipbx format. So first, you have seen that whenever you're performing, yes, whenever you're developing a schematic model, it will be saved in .tac format. Then after compiling that model, the model is compiled in .cpd format. And after that, the SCADA panel which we open is being saved in .cus format. Okay. Now the model settings part is there, which we save as .runx format. So these four types of file format you have seen right now in Typhoon HIL, but here it is being saved in .ipvx format. This is the PV curve for the photovoltaics which you are generating from this waveform generator. Okay, so you need to remember that this .ipvx file is for this PV settings file. Okay, so this is you need to remember. And how you'll find this data like VOC, IC, number of cells. How you'll find any data? Any idea from anyone from the participants that from where you will find this data? Anyone? Am I audible to you guys or not?
Usually, solar panels do have data sheet. Uh,
Yes, exactly. So, whenever we buy any PV panel from the market, or if we search in the internet as well regarding that PV manufacturers in India or outside India, okay. So we basically find the data sheet which comes along with it. So onto that, we'll find all this data over there. Okay, like this VOC data, IC data, what are the values of it, and then we can generate the same kind of PV characteristics over here. Okay, and we can save it and we can use it in our schematic model. So that is the basic thing. And if you have detailed data, then you need to select this option. First, you need to select generate PV. Then you need to select this option detailed. And if you have detailed data, then you can provide this parameter and you can generate your PV and IV curve. And after that, you can save it. And that file, you can use it into your schematic model. Okay. Whenever you're designing any MPPT boost charger or any kind of model regarding to PV. Just okay. So now next you will find this option. Just a moment. Okay. So next you will find this option EN50530 compatible. So it is an European standard, which is EN50530 compatible. Okay. It also generate your PV and IV characteristics, but the thing is that here you do not need to provide all those data, like the number of cells, type of panel. Here you do not need to provide. Only you need to provide VOC and IC values, and then you need to select the type, whether it is CSI or thin film, or you can select user defined if you know the data for your PV panel type. Okay, and then you need to provide irradiation and temperature, and same thing, you need to click on preview and then you can generate the PV curve. Let me just change over here, make it 40 and click on preview. Then you can see it is being changed. Okay. Similarly, you can change, just enter random values and you can check on preview. Okay. So these are the two options over here. One was already we have discussed as detailed. Second is EN50530 compatible, and next is normalized IV. Now, in case of normalized IV, if you have any IV data along with you in .csv format, sometimes what happen, this PV manufacturer type gives some data in .csv format, not like they return this. This is the VOC parameters or IC parameters like that. They will not give the data like that. They will just give you a .csv file to you directly, and what you can do, you can just browse that file from here, and you can click on preview by just providing changing your IC and VOC data over here. Okay, so that option is also given over here to generate, and after generating, you need to click on save to save the file, which we can again use in our schematic. Okay, so this is the use and this is the application of this PE file generator. And next we'll see what is available in import IV option. So first you have seen what are the available options are there for generate PV, and now we'll check on import IV. Okay, so if you click on import IV, similarly it will ask you the file. So I told you, as some manufacturer give you .csv file directly, so that .csv file you can import it from here directly. Just actually this file is not supported, so similarly you can import any .csv file which is available with you and provided from the manufacturer side. Okay, so that you can import and you can generate the PV and IV curve over here directly. So these are the all options which are available in PV file generator. If you want, you can explore, and if you face any issues, any queries are there, you can just ask me directly. Okay. Now, what we'll check next, we'll find this option source file generator. Okay. So Similarly, like PV file generator, what we have done, we have generated the PV data, PV curve, we have generated the IV curve, and we have saved the data, okay, in .ipvx format, and that file can be used in a schematic. I'll show you when I develop the model for MPPT boost charger, that if you have any .ipvx file, then where to where to what say load that file and how to load that file. Okay. So I'll provide you the detailed step that how to do that. In MATLAB, what we do, we just provide this VOC icing data. We directly drag an PV panel. We provide data over there directly. But here in real-time simulation mode, this option is been given on SCADA. Why it's been given on SCADA? The thing is that you can, as we know, the SCADA by SCADA we can change parameters during runtime. So that's why it is being provided in SCADA that you can change the PV panel type during running simulation. It's not, it will be remain fixed. You have selected one PV panel type, it will remain fixed for the entire duration of the simulation. Okay, so it's not like that. You can change the PV panel type. You can change from normal PV panel type to shaded PV examples. Okay, so that's why it's been provided on HIL SCADA. Okay, so now you will have this option as source file generator, which is the second tab available over here in Typhoon Waveform Generator. Okay, so here you can find an option to add new signal, low, open, and also save kind of thing, just which is available for every tab. Okay. Also here you will find some option like apply mathematical part. I'll show you how to do that. Time step, time unit as microsecond. All the options are given over here. Some options are given over here. I'll discuss that part in details. So let me just first add a signal. So how to add a signal? You need to just click over here, click on add new signal, and here you need to select the signal template. Okay, so if you want to design a new source file, so you need to select that first what template you want to use, like sinusoidal, you can use DC constant, you can use sawtooth, you can use square. So as per your source, you need to select first that what is your signal template, and then you can uh, create your own source file by changing the values or by editing it over here. Okay, so first I have select a signal template as sinusoidal. You can select any one of it, okay, as per your convenience. It's not limited that you need to select only sinusoidal. Okay, and then I'll provide some RMS value. Let's take an example. I'll take 230 RMS value. Now in Typhoon HIL, whenever you enter any values, it will be highlighted in red color. Okay, so to remove that, you need to click on enter. So until and unless you do not press enter on your keyboard, this value will not get inserted over here. Okay, or this value will not change. So whenever you're changing any parameters, whenever you're changing any values, you need to just provide the parameters first, and then you need to press on enter. Okay, so now you can see that red color highlighted is being changed into white color. Okay, now here you can change your frequency. So I'll go with the default frequency 50 Hertz. Okay, from here you can also change your phase. So I do not want to change any phase, and from here you can change your periods. Okay. So I'll take it on 5. And if you want to inject any harmonics along with your source, then you can select this option. Here you will find the option to select the type of harmonics. You can provide the value for the harmonics over here, and you can then insert the signal. So right now I'll not use any harmonics. I'll just directly insert the signal over here. So here you can see your sinusoidal signal of period 5 has been inserted, okay, with 50 Hertz frequency. Now, if I want to edit the signal, so for that, first I need to select a part of it. So first I have created this option, rectangle select. After clicking onto it, here you can see red dots is appeared onto the signal. Now I want to change this part. Okay, this is just an example. Okay, so if I want to select this part, I can select this part in this way. I can do that. Okay, let me just select it once again. So now you can see this part is been selected, and now if I want to modify this part, so I can either use, I can multiply it, add it, okay, or I can just use this part and drag and drop it, okay, move it directly in this way. Okay, so this is the one option using this. First, what I have done, I have selected the a particular part which I want to edit. Then I have selected the part which I want to move, in which direction I want to move. Okay. So now I have taken it on the default. Now, if I want to add or multiply using some mathematical function, so I can go over here, provide them a value, and so now you can see it's being edited. So similarly, there are various options are available over there. First, you need to select, then you can edit it using this toolboxes available over here. Also, you can change the time duration. Here you can see the time is in microsecond. You can change it on seconds. You can change it on milliseconds. Okay, so that also depends upon your requirement. So similarly, if I want to change another part, so just take this part, okay, and I want to add it. So I just enter a value, a random value, and I've done it. Let me just add it with Qt. In this way, you can change your source file, and after changing or after modifying your source file, what you can do, you can save it. So if you click onto it, you can see it has been saved in .izg format. So we have generated the PV in which format? Anyone? What was the format over there?
IPVX.
Yes, correct. Yes. Anyone?
Yes, sir, it was IPVX.
Okay. So previously it was IPVX, but for source file it is in .isg format.
ISG.
Yeah.
ISG.
Yeah, for source file it is .isg format. Okay, so that's the difference. Previously it was .ipvx, now it is ISG. Okay, so in Typhoon HIL you need to remember .tsc for Typhoon schematic editor, which is its full form, tsc. Then we when we compile that model, it is generated in .cpd format, but we generally do not means we do not require .cpd format. If you want to share that model to anyone, .cpd format is not necessary. Whenever we compile, it is generated automatically, okay, in background. Now next, after the model is being loaded onto SCADA, we select a panel, we create a new panel, and that panel has been saved in .cus format. Okay, and next we have this settings file which is saved in .runx. And after that, if you use this waveform generator, then that p file generator saves the file in .ipvx, and this source file generator over here generates file in .isg format. Okay, so if you save that file and if you want to use a schematic, I'll show you what from how you can call that file. Okay. So these are the options available over here. If you have any queries, any questions to ask, you can unmute yourself and you can ask. Else, we can move to the schematic modeling. So any queries from anyone? Any doubts, any queries if you want to ask?
सर जो नीचे अदर एडिशनल टूल्स हैं इन सब का यूज
सेम ही है इन सब का यूज. बेसिकली मैंने मूवमेंट जो किया था पहले अप एंड डाउन किया था, आप साइड वाइज मूवमेंट कर सकते हैं. ठीक है, सो सेम ही है.
ओके सर.
ओके, प्लस अगर आप यस
एक्सप्लेन वंस अगेन फॉर पीवी फाइल जनरेटर.
यू आर नॉट देयर.
सर बाय मिस्टेक वाज disconnected.
Okay, so basically, as the name suggests, p file generator, I'll just go to the default. Whenever you open the waveform generator, it will look like this way. Okay, so here you'll find the p file generator, and then you'll find the source file generator. So then in p file generator, you'll find the mode like generate PV, import IV, and here you will find the PV model like detailed EN50530 compatible normalized IV. And here in detailed settings, you'll find this option to provide the values. Now, if you have any PV data, okay, like those who are in NIT, those who have this PV simulator kind of thing, what they do, they just take a PV panel and they just put a bulb over it and they generate a PV curve onto that. Okay, but Typhoon HIL has given this option to generate your PV file type. What you need to do, you need to take the manufacturer data for the PV, like VOC, all this data you can get it from their website, or whenever you click on PV panel, you can get the datasheet from there directly. Okay, so you will get all this data from there. From here, you can select a type of panel like CSI or amorphous silicon. Okay, you can select the number of cells, and then you can provide your irradiation and temperature and click on preview. So after click on preview, you can find the PV and IV characteristics generated automatically using the software. Okay, and after generating, if you want to use this file in your schematic, then you can save it from here, and this file would be saved in .ipvx format. Okay, so these are the options. If you have detailed data of your PV panel, then you can use this detailed options. Else you can use this EN50530 compatible, where you need to only provide the VOC and ISC data. Okay, and from here you can select the type of panel like thin film or CSI, or if you want to provide user-defined panels, then you can select the user-defined options over here, provide the technology settings, and then again provide the radiation and temperature. Like if I provide 50 and click on preview, so again you can generate the PV, IV, PV and IV characteristics of your PV panel. Okay, so these are the two options available over here. Now, sometimes what happens, the manufacturer directly give you .csv file of their PV panel. Okay, so that you can call using normalized IV, or you can call using this option import IV. So here you can just directly call that .csv file, and you can import, you can plot it over here directly. Okay. So these are the options available in P file generator. I hope it's clear now. Is it?
Yes, sir.
Okay. So any other doubts, any other queries from anyone?
Sir, how to open that file means into our schematic?
Yeah, that I will show that if you have saved a .ipvx from PV file generator, or if you have saved a .isg format file from source file generator, then how to call that file in schematic, I'll show that. Okay.
Okay, okay, sir.
Yeah. So any other queries from anyone? Or else I will just move to the schematic and start developing the model for PV MPPT boost charger. Let me just check once. Okay, so I think there is no query. Okay, then I'll just close this window, and then I'll just open the schematic. So everyone, you can, if you want to develop the model along with me, then you can just directly open the schematic. We are going to start the modeling part. Okay. So after clicking on schematic, everyone knows that we'll find these recent schematic files, and here you will find the example explorer. That whatever the example models which are already inbuilt available in Typhoon HIL, you will get the details over here. Else you can go with the file, and here you will find the option for opening any model, or you can just click on new and new model, and you can develop your new model. Else, if you want to create a new library in Typhoon HIL, then these options is available over here. Okay. So regarding that, creating a new library, we'll discuss this part in some Saturday. Okay. That how to create a new library in Typhoon HIL, that we'll discuss. So today is not the right day for discussing that part in details. Also, here, if you want to import any PC model in Typhoon HIL for real-time application, then you can use this option, import PC schematic. Okay. So I'll just go to new model, or else you can directly click over here, this plus sign yellow button over here. Okay. And then it will ask for settings like HIL 402 hardware configuration ID. So if you have any particular device along with you, then you can select this device from here. Okay. Else you can just select the VHL device. Okay. So now I'll go with the default device, which is HIL 402, and I'll not change any configuration ID. And then I'll select the simulation method like exact trapezoidal ILR. You can select as per your application. Else I can go with the exact. And now I'll click on next. The settings would be default. Click on finish. So after clicking on next, it will ask me for review that whatever the settings I have done. And then next, it will take a little bit of time to load library and then open the blank page with current date and time. Okay, so here you can see that blank canvas is opened now with the current date and time over here. And here you already know that we'll find the library explorer components. So we'll start developing the model for MPPT, PV MPPT boost charger. So for that, we first require a photovoltaic panel. So where we'll find the photovoltaic panel? So as PV is our source, so we'll go to sources, and from here we'll find this photovoltaic panel over here. So I'll just drag and drop a photovoltaic panel. Okay. Then what the main components we require, as it is an MPPT boost charger, so we require a boost converter. So I'll go to converters, and from here I'll just drag and drop a boost converter. Okay. So by using this figure, you can find that here the diode and the IGBT switch is there. Okay, but we need to use an inductor over here. So for that, we'll go to passive components and drag and drop an inductor. So now our boost is completed. Okay. Now what we'll take some passive components we'll require. So I'll take one resistor, and I'll take another resistor for my ESR part, and then I'll take a capacitor. I'll rotate it, and then I'll take a battery. So again, battery is my source. So for that, I need to go to sources and drag and drop a battery and place it over here. And then I require some passive component for my load. So for load, I'll take two resistor, one and two resistor. Okay. So everyone drag and drop and place it like this. I'll just wait.
Sir?
Yes.
Sir, are we going to charge a battery from the
Yes.
solar?
Yes.
solar panel?
Yes. So for that, we are going to develop a controller for that also. Okay.
Okay.
Yeah. So up till now, is everyone done? Means have you drag and drop these components which I have placed over here, or else you can do it later onwards. I'll give you your time. Okay. So now what I'll do, I'll just take some measurement components for measuring the voltage and current across some parts of my circuit. So for that, I'll take first a current measurement to measure my PV current, and a voltage measurement. Sorry, there is another one, voltage measurement. Yeah. So a voltage measurement, I'll place it over here to measure the voltage across this PV panel. And I'll take another voltage to measure the voltage across the inductor over here. And I'll take another current measurement over here to measure the output of this boost, and then one current measurement to measure the overall output, and one voltage measurement already over here. So I'll just place it over here to measure the output voltage. This voltage measurement I do not require. And I'll take another current measurement to measure the current across the battery, and another two current measurement, one across this load and one across this load. Okay. So these are the components which I have taken. First, photovoltaic panel. Then we have taken two measurement blocks, one for voltage measurement, one for current measurement. Then we have taken a resistor, then an inductor. Over inductor, we have taken a voltage measurement block to measure the voltage across over here. Then we have taken a boost converter, then a current measurement after this boost converter. Then we have taken the capacitor over here for filtering purpose. And here we have taken current and voltage measurement blocks to measure the voltage and overall current. And then we have taken this battery. For battery current measurement, we have taken this ammeter over here, or the current measurement block. Then we have taken two loads or two resistors over here, which will act as my load. So for that, we have taken two current measurement block again to measure the current overhead. Okay. Then we'll take two contactors. So I'll just close it. I'll go to contactors, go to ideal. And from here, I'll just take single pole, single throw contactor to switch my load. Okay. For switching my load, I have taken two contactors. So these are the basic components I require for my plant designing, plant part. So over here, you can see every component is now in black color. So this part is my electrical part, and it is being processed by the FPGA processor whenever we perform real-time simulation. Now, when we develop the controller part, it will be highlighted in blue color. That will show you that what is the difference between the plant and the controller side. So in Typhoon HIL, you will find these components which will be present in your electrical part as black color. Okay. So you just drag and drop this component first and place it like this way. Then we'll start connecting and wiring this model. Okay. So please let me know if you're done. Means if you're just drag and drop these components. Is it done? Up till this part, is it done?
Yes, sir, it is done.
Okay. So I'm moving forward. So first, what I'll do, I'll just rotate all the components which were required. So first, I'll rotate this photovoltaic panel. Then I'll rotate this voltage measurement. Then I'll rotate this voltage measurement over here. I'll rotate this battery. And I'll rotate this two resistor. I'll first select it and then rotate it. Okay. So that's it, done. Now we'll connect this part. So for connecting, you need to just place your cursor onto this button, green button. Okay. So whenever you just place your cursor onto this green button, it will be highlighted in red color. Then give a click whenever it is highlighted. Now you can see a plus sign will be appearing onto it, and you can just move this. Whenever you are moving this cursor right now, if you're moving it, then the wire will move as per the movement of your cursor. Now you need to go to the place in which you need to connect, and then again it will be highlighted in red color, and click onto it. Now it's connected. Okay. So in this way you need to do the connection, and I'll do the connection over here. Same way, I'll place it in proper manner and connect these components. Now I'll connect this inductor over here, and then with the input port of boost converter. And over here, I'll connect this voltage measurement block. Okay. So that's it. We are done. Okay. So this part connection we have done. Now what we'll do, we'll move towards this side and connect this part. So the same way I have placed the components so to connect it easily. So I'll just connect the components which I have placed, make some adjustment to make the circuit look good. And now I'm connecting all those. Similarly, here I require I need to rotate it basically, this current measurement and this battery, and I'll connect. Okay, and then I'll place this contactor over here, and I also need to rotate, which I forgot it previously. I need to rotate this current measurement block, make it in proper adjustment alignment so the circuit looks good. Yeah, in this way, and I'll just connect. So I'll connect this, and then I'll connect this contactor over here, the second contactor, and this current measurement register. So in this way, you need to make the connections right now. And after you're done, please let me know whether you're finished or not. Then we'll move to the next section. Okay. So the same way I have placed all the components, I've just connected it and placed it in a proper alignment way. So up till now, is it done?
One minute, sir.
Yeah, sure. Take your time.
Completed, sir.
Okay, so everyone completed or should I wait? Is it done?
Done, sir.
Completed.
Done, sir.
Okay. So now what I'll do, the next step, I'll just rename every component available over here. Okay. So I have just connected and now I'll do renaming every component, and then I'll just enable and disable some parts of component which I require for my controller development. Okay. So first I'll start with this photovoltaic panel. I'll just double click onto this photovoltaic panel, and you can say it is giving me the option to change the name. So I'll just name it as PV only. Okay. First I have changed the name for this PV, and then I'll change the name for this current measurement block as IPV, and this one as VPV. First I have done PV for this photovoltaic panel 1. Then for this current measurement block, I have made it as IPV. Then for this voltage measurement block, I have done as VPV. I'll just change the name for this resistor as RL. and this L1 inductor as L only. And here this voltage measurement as VL. So PV, then current measurement block IPV, then voltage measurement block as VPV, then resistor over here as RL, then inductor as an L, and this voltage measurement across this inductor as VL. Okay, and this boost converter, I'll just remove this one over here, and that's it. Okay, and after that we'll come to this side. I'll just make it proper. So here for this current measurement block, I'll change its name as I out underscore boost. Then for this resistor, I'll just change its name as ESR. For this capacitor, I'll just remove the one from it, make it as C. And over here, this current measurement block as I out, and this one as V out. Then comes our battery. I just rename the battery as one as only battery, and this current measurement block as I battery. And over here, this one as my contactor underscore load. And this as I load. This one as R load. And this resistor as R discharge. And this current measurement block as I discharge. And this contactor as contactor discharge. So I've changed the name for the components which I have drag and drop. You just change the name. First, it was PV, then the current measurement block as IPV, then the voltage measurement block as VPV. Then we have changed the name of the resistor after that as RL. Then the inductor block as L only instead of L1. Then the voltage measurement block across it as VL. Okay. Then we have changed the name for the boost converter, which was previously boost 1 as boost. Then we have taken this current measurement block, which I have changed it to I out underscore boost. Then we have this resistor block, which I have renamed as ESR. After that, we have this capacitor. Previously, it was C1. Then we have changed it as C only. And then we have this current measurement block as I out. And after that, we have this voltage measurement component as V out. Okay. So then we have this battery. Previously, it was battery 1. We have renamed it as battery only. And the current measurement block across it as I battery. Okay. Then we have taken two contactors. One was S1 and the other one was S2. So we have renamed the S1 as contactor underscore load and the second contactor as contactor underscore discharge. And the two current measurement across the resistor, first one as I load and the resistor as R load, then the second one as I discharge and the resistor name as R discharge. We have not given any values, we have just changed the name of the components which we have connected. Okay. So change the name and let me know whether you are done or not. Make sure whatever the naming you have provided over here, okay, the same one which I have done, else it will be difficult for us to find that particular signals. Okay. So is it done for everyone?
Yes, sir.
Okay. So
Yes, sir.
okay. So now I'll move to the next part. Okay. So if anyone wants me to stop right now, they are copying it. So please let me know, else I'm going to move. Okay. So no response. That means you're done up till this part. Okay. So I'll just move to the next section. Now what I'll do, I'll just enable the voltage and current measurement block which I require for signal processing, and then I'll just provide the parameters for all the passive components which I have taken. So first we'll start from this section. I'll just double click onto this IPV, go to signal processing and enable the signal output. I just double click onto that, gone to second tab which is signal processing and enable the signal output. Now over here, I change the execution rate from 100 e to the power minus 6 to TS. I just defined it as TS. Okay. After defining it, I'll click on OK. Now you can see a blue color port is appearing onto the top for my single person side. Okay. Similarly, next what I'll do, I'll double click onto this VPV, go to signal processing part and enable the signal output. And then the same way, I'll change the execution rate as this. So what I have done, I have just double click onto it, gone to signal processing tab and enable the signal output. And then I have changed the execution rate to TS. So the same thing I have done for this IPV and VPV. Now, next what I'll do, I'll just double click onto this register and here I'll just provide the resistance value as R. Okay. And then for this inductor as L. So I have given the value for this resistor as RL and this inductor as L only. Whatever I have written outside it, I've just given the same, declared the same value inside it. Okay. Now here I do not require signal output port for signal processing part. So I'll not enable this one. Next, what I'll do, I'll just double click on this boost converter and here I'll change the control method to internal moderator. So all of you know what are the purpose of this control. Three options are there for display inputs. What are the options we get for internal moderator, why we select, and for model. So if you want to individually control the switches using your reference and carrier both, then in that case you need to select model. Else, if you want the inbuilt carrier which is already available in Typhoon HIL, then you can select this option, internal modulator. If you want to control the switches for this boost converter from outside using some kind of dedicated controller or some mini microcontroller part, then you can use this option, digital inputs. Okay. So I'll now select this option, internal modulator, and then I'll select fixed carrier frequency. If you want to change the carrier frequency, then you can go with the variable carrier frequency, else it's okay. So I'll select fixed carrier frequency now, and I'll select the carrier frequency as 10 kilohertz. So already 10 kilohertz is there. Phase offset as 0.0, and I'll change the dead time period from 5 microsecond to 1 microsecond. And the reference signal and minimum and maximum is -1 to 1. So I'll just change a small as -1.1 to 1.1. So these are the settings, these are the changes I have done for this boost converter. And over here, I just enable this IPV and VPV measurement block and provide the values for RL. So here I've defined as RL and here I've defined as L only. Okay. So now I'll just click on OK. And after that, you can see two ports are available. One is for enabling this boost converter, and other one is giving the reference signal for this boost converter. Okay. Now here I do not want the signal processing part for this I out boost. Here I'll just provide the parameter for this register as ESR, and then the capacitor over here as C. So here I have given ESR and here I have given C. And now I require the signal output port for this I out and V out both. So I'll just double click onto this I out, go to signal processing and enable the signal output. And here I'll change the execution rate as PS. Similarly, the same way I'll make the settings for my V out. So I'll just double click, go to signal processing, enable the signal output, and change the execution rate as PS. So that's it. We have enabled the signal processing part for this IPV and VPV, and the same way we have done for this I out and V out. Okay. Because we want to measure the power over here, also the voltage we require for our signal processing part. That's why we have enabled the signal processing part for this here. Okay. Now, what I'll do next, we do not require the signal processing part for this current measurement, so I'll not enable this. I'll just do the settings for the battery and provide the parameters for this resistor, which is R load and R discharge. So I'll just double click onto battery, and here I'll provide the settings. So I'll select battery type as lead acid. I'll go with the default, and I'll just provide the nominal voltage from 12 volt. I'll change it as 48 volt, and capacity as 10 ampere hour. Initial SOC as 100%. If you want to preview the SOC curve, you can click over here, and here you can find the SOC curve for your battery. Okay. Now, those who want to use the SOC output for the battery, for that part, you need to click onto this option to enable the SOC output from your battery. Okay. So that's the option over here. So I've given the settings as nominal voltage as 48, capacity as 10 ampere hour, and initial SOC as 100%. So after that, I'll click on it. And then I'll move to the next part, which is my R load. So I'll just provide the R load as, name it as R load. Same which I've done over here. Later, I'll declare all the variables in model initialization. Okay. I'll not defining it over here. And next, I'll have this R discharge. So what I have done in this part, I have just enabled this IPV and VPV, provided this value for this resistance as RL, here as an L, and provided the parameters for the boost converter as 10 kilohertz only, which I have not changed. It was previously over there as 10 kilohertz. Dead time period I have changed from 5 microsecond to 1 microsecond, and then what I have changed over here is this reference signal minimum maximum value. As previously it was -1 to 1, now I have changed it to -1.1 to 1.1. Okay, so that's the changes for this boost converter. Next, I have given the value, declared the variable for this resistor as ESR, and for this capacitor as C. And similar way, which I have done over here, I have enabled the I out and V out over here. Okay, and then I just provide the parameters for battery. Battery I have given nominal voltage as 48, capacity as 10 ampere hour, and initial SOC as 100%. Okay. Next, what I have done, I have changed the value for this R load, which I have defined the same name as R load, and for this resistor as R discharge, the same. So whenever you're done up till this part, please let me know, then we'll move to the next part.
Sir,
Yes.
that
Hello, sir.
boost model, I'm getting three enable pins. Sorry, three pins there. Enable, in, and frequency.
What you have done, you just double click onto this boost converter, and here you can see the operation mode as
Yes, sir.
variable
Change.
carrier frequency. Change
Variable
it to,
variable.
yes, change it to fixed carrier frequency, then it will be resolved. Change it and let me know.
Yes, sir. Resolve.
Okay. So yes, someone was asking something. Yes, tell me. Hello. Any queries up till now from the participants? Okay, so whenever you're done, please let me know and I'll move forward.
Sir, done, sir.
Okay. Okay. So now what I'll require, I'll need to calculate first the input power and then I'll calculate the output power. Okay. For efficiency part. So for calculating what I require a product block to multiply it. So for that, where I'll find this product block, I need to go to signal processing, and here I need to go to math option. Yeah. So I have to go to this math operation. Okay. So I'll click on math operation over here, and then I'll just drag and drop a product block over here and drag and drop a product block over here to calculate the input power as well as the output power. Okay. So let me just connect it. Okay. So I'll change the name. Okay, I'll do it later onwards. First, I will just connect, and over here, I'll just connect this. Okay. I'll just hide its name for this product block by right clicking onto it and click on show item. Okay. Now what I'll do, I'll take a probe. I'll go to sinks over here in the same tab, signal processing section, and I'll just drag and drop probe. If you do not find it, you can just type over here on this find component section as probe and drag and drop it and place it over here. So I'll just connect this probe over here and change its name to P underscore. So from here, I'm getting the output power, and from here, I'm getting this input power of PV power. Okay. Now, next thing what I'll do, I need to write this MPPT. In this model, we are going to do this MPPT part. So we are going to use this P&O algorithm. So for that, we need to write this P&O algorithm. Okay. So for that, I will require the power, changing power, and we require this changing voltage. Okay. So here we have got the power, and from here we are getting the voltage. So for changing voltage or changing power, we need to place a unit delay block. So we'll go to this extras, sorry, discrete actually. So here in discrete, you will find this unit delay block over here. So I just drag and drop unit delay. One for changing power and the other one for changing voltage. Okay.
Sir,
Yes.
so we are using which algorithm?
P&O.
P and row.
Yeah.
P&O, sir.
Yeah, P&O.
It's a perturb and
Perturb
observation.
and
Yeah, exactly.
observation.
Exactly. Okay. So now I'll take this connected first and this unit delay with the voltage. Okay. So this unit delay with this product block and this unit delay with this voltage. Okay. Now what I'll do, I'll take one sum block. So sum block, I'll just scroll down and get it in math operation. So I'll just drag and drop two sum block. One. Okay. So here I'm getting the change in power, and I'll just change the property of this sum block as plus minus, and this one as similarly plus minus. We connect the output of unit delay with this one and this to this. So from here I'm getting the change in voltage, and over here I'm getting the change in power. Del P and del V. I'm getting it. Okay. Here I can connect a probe to measure the PV power. So let's just do one thing. Just select this, copy and paste, or you can just drag and drop a probe directly from the signal person and connect it. So I'm just connecting it and change its name as P_PV. So that's it up till now.
So by using the sum block, we can getting the PV power now.
No, we are getting the PV power over here.
By product.
Block. Yeah.
One.
So that's why we have connected it now on the output
Okay.
side. Okay.
Yes.
From sum block, we are getting the change in power and change in voltage. So how to make the change? We have placed the unit delay over here.
Okay, sir.
Now what I'll do, I'll take the C function block to write the algorithm. So you will find the C function block onto this functions and table, and here you'll find this option C function. Okay. So I'll just drag and drop the C function block over here, and I'll just change the name for the C function block as P and O. So now what I'll do, I'll just double click onto it, and here I'll write the inputs. So first input is my power, change in power basically. So I'll write it as power, represent it as power. And second, I'll represent it as voltage. And click on it. So this is my change in power I'm getting from here, and voltage I'm getting it from. So do up till now, and please let me know whether you've completed or not.
Sir, from where you get P and O?
Actually, this is not P and O, this is C function block. You'll find this in functions and table, C function block, this one.
Yes, sir, yes, sir, and rename it P and O.
Yeah, I have renamed it as P and O.
Sir, please show the C function block once.
Yeah, see what I have done in C function block, I just double click onto it. On the inputs, I have just taken two part. One is power and voltage. I have added it. One, first it was changed the input as power, and then I have added one as voltage. Okay,
Okay, sir.
power and voltage.
So one type is real and another is inherit.
You can make it real also. That doesn't make any change. Inherit means it will take back the properties from the previous block. Real means
Yes.
it will take its own. So after taking this power and voltage, if you click on OK and close it anyways, then you'll find two input port available over here. Okay. So I'll require two input port. First one is my change in power and change in voltage. So I've taken it over. Also, you can find these blocks are in blue in color. So all the signal processing part in Typhoon HIL will be represented in blue color, and it will be handled by the ARM processor of your real-time simulator when you're running this model on real time. This black part would be handled by your FPGA processor, and this blue part is being handled by your CPU processor, which is your ARM processor, ARM processor. So if you're done up till now, please let me know, then I can move forward.
Sir, from which processor we can handle black part?
Basically, the main processor for Typhoon HIL is FPGA. So all the electrical components which is represented in black part is being used by the FPGA processor. Okay. Else the signal processing part, like this blue part, which you can see, this blue part, this all is being solved by the ARM processor or the CPU processor, which is available in Typhoon HIL. Basically, the CPU processor is ARM over here, ARM.
Okay, sir.
Yeah.
Sir, ARM complete processor name is?
ARM, it's ARM.
Yes, sir. ARM Cortex something or only ARM?
It's ARM Cortex A9, I think so. I need to check once actually. Actually, this ARM processor is different for this real-time simulator. Okay.
Sir, actually, I'm currently studying. That's why I'm asking.
So for that, you need to just go to this Typhoon Control Center, go to Documentation Hub.
It's an ARM Cortex A9.
Yeah, it's ARM Cortex A9. So here you need to click on HIL 46 Hardware User Guide. Okay. And if you click on General Specification, you'll get the details over here.
All right, sir. Thank you.
So done up till now?
Yes, sir.
Okay, so we have declared the inputs. My two inputs are power and voltage. So next we'll move forward to the outputs. So we'll make output as out, the same. Okay, will not make any changes over here. Now we'll require to define some variables for my P&O algorithm. So I'll just add, I'll require 1, 2, 3, 4. Okay. So my first variable is duty cycle. So I'll rename it as duty underscore cycle. My second variable would be delta duty cycle. So I'll rename it as delta underscore duty underscore cycle. And my third variable would be minimum value, which I'll define it as minimum val, and then maximum value, and then step. So these are my 5 variables which I'm going to require to write my P&O algorithm. Okay. So which I need to define over here in this variable section. So first is duty underscore cycle, second is delta underscore duty cycle, then minimum value, which I have defined as minimum value, then maximum value, and then step. Okay, up till now, noted.
Yes, sir.
Okay. So now I'll go to functions.
Yes, sir.
And if you click on functions, you will find this option as output function, where I need to write the main code. Then you'll find this initialization function, and then you will find the update function. So if you have any timer related kind of code, then you can write it on this update function. And if you want to declare any initial parameters, then you need to type over here. Okay. So I'll just define some initialization as duty cycle, duty underscore cycle would be equal to 0, and delta duty cycle would be equal to 0.001, and maximum value would be equal to 0.9, and minimum value would be equal to minus 0.2. Okay. So these are the initialization which I have declared. Their duty cycle as 0, delta duty cycle as 0.001, maximum value as 0.9, and minimum value as minus 0.9. Okay. So whenever you are done, please let me know.
Done, sir.
Okay. So now we have declared the initialization part and the initialization function, and now we'll move to our main code, which is the output function. Okay. So first we'll define or declare as if bracket power, which is my first input, would be equal to 0. then condition open. Step would be equal to 0. Condition close. So this is my first condition. If power equal to 0, then step would be equal to 0. Make sure you provide proper brackets and then open the condition and maintain the specific gaps. Else we can also rectify it after the writing of the code by using this check syntax. So my first condition is if power equal to 0, then step would be equal to 0. Now we'll write the next condition. Else if bracket open power is greater than 0, then condition open. Then the next condition inside it is if voltage is greater than 0, then step would be equal to minus 1 into delta duty cycle. Delta underscore duty underscore cycle. Now the next condition inside is else step would be equal to delta underscore duty underscore cycle. Delta duty cycle. Condition close. So my first condition was if power equal to 0, then step would be equal to 0. Else if then the next condition is power is greater than 0. And inside the power, if voltage is also greater than 0, then step would be minus 1 into delta duty cycle. Else step would be equal to delta duty cycle. Okay. Now we'll write the second else if condition. Else if power is less than 0, condition open, and if voltage is greater than 0. So when power is less than 0 and voltage is greater than 0, then step would be equal to delta duty cycle, delta underscore duty underscore cycle. Else step would be equal to minus 1 into delta duty cycle. Condition close. So my first condition was this, then we have entered if power is greater than 0 and also voltage is greater than 0, then step would be equal to minus 1 into delta duty cycle, else it would be equal to delta duty cycle. Then the next condition is if power is less than 0 and voltage is greater than 0, then step would be equal to delta duty cycle, else step would be equal to minus 1 into delta duty cycle. Okay. Now we'll define our duty cycle. Duty cycle would be equal to duty cycle plus step. Duty underscore cycle plus step. Now we'll write another condition. If duty cycle is less than minimum value, then duty cycle will be equal to minimum value. Else, if duty cycle is greater than maximum value, then duty cycle would be equal to maximum value. Then our output would be duty cycle. Our reference would be duty cycle. So this is the code. I'll just do one thing. Check its syntax, no errors found. I'll just copy this and I'll just paste it on the chat box. I have copied and pasted it into the chat box. You can copy it and paste it. Okay. So I've checked the syntax, no errors found. Please let me know when you're done by writing this code. So it's simple code. First we have declared if power equal to 0, then step would be equal to 0. Else, first condition is power is greater than 0, then also voltage would be greater than 0. Then step would be minus 1 into delta duty cycle, else step would be equal to delta duty cycle. And then we have declared if power is less than 0 and voltage is greater than 0, then it will be reverse. Step would be equal to delta duty cycle, else step would be equal to minus 1 into delta duty cycle. Then we have defined the duty cycle, which is our output. So duty cycle would be equal to duty cycle plus step. Okay. And if duty cycle is less than minimum value, then it should be equal to minimum value, which is minus 0.9, which we have declared over here. Else, if duty cycle is equal to greater than maximum value, then duty cycle would be equal to maximum value. Maximum value we have defined it as 0.9. Okay, and delta duty cycle we have defined as 0.001. Then our output we are getting is duty cycle, which is our reference signal for the boost converter. So up till now, if everyone is done, then please let me know.
Done, sir.
Okay. So what about others? Are they done?
Sir, I am
Yes,
getting
sir,
error.
done.
You are getting error.
Yes, power undeclared. First use this function if.
Power undeclared. Have you written on this part if power like this? P capital?
Yes, sir. I think I have space 1 after the bracket. That's why getting error.
Yes, this is, there is a space after the bracket.
So then also getting error.
Okay, do one thing, go to general and go to inputs. Have you written the power over here in the same way?
No, P small I have written.
Yes, that's why you are getting that error.
Okay.
Change it and check syntax and let me know.
Okay. So then also getting error. Same
Then
only.
also, then also you're getting error.
Yes, I have
Okay,
copy paste only code.
you have written this power voltage in the same way, right? P capital, B capital.
Yes, in general
Yeah, general inputs.
inputs. Yes.
Outputs is out, right?
Yes.
And have you checked these variables?
Yes.
Same way, duty cycle, delta duty cycle, minimum value, maximum value, and step.
Yes. Both variables are correct.
Okay. And have you declared this initialization function?
Yes.
Okay. So means after writing this code, have you given a bracket over here? Then if you have copied the same code, there shouldn't be any error over there.
Yes. So now it's getting error in one error is solved, one error is remaining.
Which one? What is the error right now?
In initial function, delta duty cycle undeclared.
Delta duty cycle undeclared. So here you need to go to generals and variables. Here you need to write in this way, delta underscore duty underscore cycle. Check whether you have written it in that way or not.
Yes, that's the same.
Is it same delta underscore duty underscore cycle?
Yes.
And over here, have you declared it in this way? Delta in this initialization function, delta underscore duty underscore cycle is equal to 0.001.
Yes, checking, sir.
Yeah.
So in output block, general output block, please show
I have
out
not
one.
I have not changed anything over here.
Okay, sir.
It's just out. Whatever
Out.
it was there, only I have changed in general the inputs and the variables I've declared. And then I've written the functions in the initialization function and then output function. So is your error resolved or not?
Yes, sir, solved.
Solved. Okay. So should I move
Yes.
forward now?
Yes, sir.
Okay. So from here I'm getting the reference signal for this boost converter. Okay. So what I'll do, I'll take a from block. Sorry, go to block actually. I need to send the signal, so I require a go to block. So over here, you will find in this system, not in system actually, you will find over here in the system, not here in the signal processing. After the sources in this system, you will find this signal go to, or else what you can do, you can just type it over here as signal go to. Okay. So I'll just drag and drop this signal go to and place it in. Now I'll hide its name. Just right click onto it and hide its name and connect with it. Now, if I double click onto it, you will find the scope as local, global, mark subsystem. Okay, so many of you have confusion that what do you mean by local, what do you mean by global, and what do you mean by mark subsystem. So local means if I want to connect any signal here in this root means this part, okay, here inside. So if I make it global, so it will be available over here directly. But if I make it as global, then it will be available in root as well as inside a subsystem. If I create a subsystem over here and I want to send this particular signal inside that subsystem, then if I make the board tag as global, then it will connect. Else, if I make it global, then it will not be visible inside that particular subsystem. Now, there is a third part which is mark subsystem. Mark subsystem, if you have seen that Sld model regarding electric vehicle, in that model, what we have done after developing the subsystem, we have just created a mask of it. Means we have put an image onto that particular subsystem. Okay. So that is known as mark system subsystem. Whenever we provide any image or any properties to a particular subsystem, then you will have this option as mark subsystem. Okay, we create a mask of that particular subsystem. So in that case, if I want to make this tag visible over there, then we need to select this option, which is mark subsystem. I hope this part is clear. If anyone is having any queries regarding this part or want to repeat me once again, then you can let me know. Is it clear for everyone?
Sir, repeat for mark system.
Uh, have you been seen that Saturday demonstration regarding electric vehicle?
Yes, sir.
So if you remember, first what we have done, we have developed taken the inverter, then we have taken the motor, and then we have taken the battery. And that part we have make it as electric vehicle, and then we have developed a charging system for that electric vehicle using a grid. Okay, and we have created a subsystem of it. One
Yes, sir.
subsystem as electric vehicle, one subsystem as grid, and one subsystem for charging part. Okay, so there was three subsystem onto that model, and over to that model we have marks it. How do we basically we have taken an image for the electric vehicle or for the charging station. We have taken an image for that, and we have placed that image onto that particular subsystem. So that subsystem is known as mark subsystem. Okay. So
Yes,
whenever
sir.
we mask any subsystem, that is known as mask subsystem. How to do that? You will find that onto that example model. That basically this particular system is marked. Okay, and to send that signal inside the mark system, we need to select this scope mode as global. This mark system. Okay, then it will be visible inside that. So that's a difference.
Sudipto, let's have a break.
We'll take a break on 4:15.
Okay.
Yeah. So I'll now make it as local and change the tag as reference. Make sure R is small, else you will find again an error. It's reference REFE, or else whatever you provide the tag name, make sure that tag name connects with the from log. So I'll click on OK, and now we are getting the reference signal over here. Okay. Now what I'll do, I need to charge and discharge this battery. So what I'm going to do, I'm going to charge and discharge the battery by turning on and off this boost converter whenever I require. So by enabling and disabling this boost converter, I'm going to charge and discharge this battery. Okay. So first, from here, I'm measuring the output voltage. Okay. So let's take to comparator. So where I'll get a comparator? Comparator is available in this logical operations. So here I'll get comparator. So I'll just drag and drop to comparator. Okay, 1 and 2 to compare the upper and lower limit of this output voltage to charge the battery. Okay. So I'll connect the negative part to this output voltage over here and the positive part. And I need to provide the limits to compare. So for that, I require a constant. So I'll go to this signal processing sources and I'll drag and drop two constant, one for this lower limit and another one for the upper limit. Okay. Now I'll just change the name for this comparator. as CMP underscore low, and this one as comparator underscore high. So CMP underscore high or upper. We'll make it as upper. So upper limit and lower limit. Okay. Now I'll change the name for this constant as battery underscore lower limit, low underscore limit, and this one as battery underscore upper limit, battery underscore upper underscore limit. Now I've changed the name and I'll change the value. So my lower limit would be 49, or I can make it as 40 also. So first I'll make it as 49 and change the execution rate as TS. So basically for all the block, I have taken the execution rate as TS. And now I'll change the properties for this constant, change the value as 52 and execution rate as TS. My lower limit and an upper limit is 52. So whenever my this voltage goes above 52, it will discharge, means it will disable this boost converter. Okay. And whenever it goes 49, it will enable. That's the property. Now I take alt. So where I'll get this flip flop extras, you will find this SR flip. Okay, and I'll run. Okay, so from here I'll get the enable signal, and I'll double click on this SR flip flop and change the initial value as 1. Okay. So by default, it will be in on mode. And now I require a from go to block. So I'll just scroll down and here I'll get the go to block. I'll connect it onto this tag and change the name as enable. Focus local pixel, and I'll hide its name. Okay. So complete this part and we'll have a break. We'll start again by 4:30. So it's 15 minutes break. So we'll start by 4:30. I'll just mute myself.
Sir,
Yes.
Explain once SR flip-flop.
Regarding SR flip-flop, I'll show you,
Yes.
but develop it first, and then I'll let you know. Okay.
There is any change in SR flip-flop?
Yeah. Yes, I have given the initial value as 1. Okay. Here the initial value is as 1. Okay.
Okay, sir.
So let's have a break. We'll meet at 4:30.
सर सर
हेलो, यस।
सर सर ये एसआर फ्लिप फ्लॉप लोअर लिमिट पे वर्क नहीं करेगा।
लोअर लिमिट में वर्क नहीं करेगा।
सर अगर 48 वैल्यू हम डालेंगे तो सर आउटपुट जो एसआर फ्लिप फ्लॉप पे आएगा वो 10 आएगा, और 10 केस में जो क्यू वैल्यू होती है वो 1 ही रहेगी।
हाँ, तो 1 मतलब क्या, वो एनेबल ही है ना।
सर तो डिसेबल करनी है ना, हमें तो हमें लिमिट में रखना है ना।
जब मेरा वोल्टेज कितना होगा,
48।
तो 48 के नीचे ही तो हमें चार्ज करना है ना। जब 49 के नीचे ड्रॉप करेगा तभी तो हमें चार्ज करना है, जब 52 के ऊपर जाएगा तब हमें डिसेबल करना है। यही तो
अच्छा,
लॉजिक है, यही तो लॉजिक है। जब
तो
52
सर
के
ये
ऊपर जाएगा तब वो डिसेबल मतलब 0 देगा, ठीक है। और जब 48 के नीचे जाएगा तो वो एनेबल कर देगा, मतलब 1 देगा क्यू पे, ठीक है।
और सर 49 से 52 में भी इनेबल रहेगा।
हम्म
अच्छा, तो सर फिर
52 के
49 लिमिट देने का फायदा क्या है? सीधा 52 से ही कंपेयर करते हैं कि
लेकिन
ग्रेटर
हमें
देन 52 पे डिसेबल।
एसआर फ्लिप फ्लॉप में फिर कैसे करोगे, फिर तो नहीं हो पाएगा।
सर सर सीधा कंपैरेटर से डायरेक्ट इनेबल पे दे दे दो 10, तो 52 से कम रहेगा, तो उसका आउटपुट इनेबल 1 रहेगा नॉट गेट लगा के, और अगर 52 से ज्यादा होता है
हाँ, तो कॉम्प्लेक्स
तो
नहीं हो
सर
जाएगा थोड़ा सा, इसीलिए
अच्छा
सिंपल है,
ठीक है।
इसीलिए। हाँ, कर सकते हैं लेकिन वो कॉम्प्लेक्स हो जाएगा, इसीलिए सिंपल है इसका किया। ओके।
ठीक, ओके सर।
Okay, welcome back everyone. So is my voice audible?
Yes, sir.
Okay, so then we are going to start session.
Sir,
Yes.
sir, I am getting some error in this C function.
What is the error? Can you tell me?
1 second, sir.
Yeah.
Sir, it's saying delta underscore duty underscore cycle is undeclared. First using this function. Step equals to minus delta underscore duty.
Okay, it's giving the error onto line number 6. I think step equal to -1
Yes,
over
sir.
here,
Yes, sir.
right?
Yes, sir.
Do one thing. Check the initialization function. Have you written it like this way? Delta underscore duty underscore cycle equal to.
Yes, sir. 1 second. Yes, sir. Right.
Is it in the same format? D small and you have given the underscore over here.
Yes, sir. Right.
Okay. Now go to general and then go to this variables.
Variables. Okay.
Check.
Okay, sir. Duty in after duty there is no underscore. Right, sir.
Yes, 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 yes,
Okay.
yes. So
Got
do
it.
that and check and let me know.
Okay, sir. Delta duty underscore cycle. Again, sir, it is giving the same error.
Have you written over here in the variables delta underscore duty underscore cycle?
Yes, sir.
A same line error or different error?
Same, sir. No, sir. Maximum.
Maximum value undeclared.
Yes, sir.
So check these variables whether you have defined or not over here. Duty cycle, minimum value, maximum value step, have you declared it properly or not? Check that.
Sir, 1 second.
Yeah.
Oh, sir, by mistake I declare only one minimum variable. I didn't declare maximum.
Yeah, so declare all this like duty cycle, delta duty cycle, minimum value, maximum value, and step.
Yes, sir.
Okay, then it will work. Okay.
Yeah. And sir, one more. Sir, can you just review that the block which we created, that current and voltage which is some product and then it is being delayed. So what is exactly? I don't understand with the C function.
Here,
Yes, sir.
see, first what we have done, we have taken this voltage and current, and we have taken a product block. So what will you get after product block?
Yes, sir. After that,
No. What will you get? Tell me.
okay,
Let me know. After product block, what I will get over here?
power.
Yes. So this is PV power. Okay.
Yes.
And then we need to make a change in power. So for that, we have placed a unit delay block. Okay.
Yes, sir.
So here in the sum, we are taking this change and we are comparing it with the previous. So here we're getting the del P and del V. Here from here we are getting the change in voltage and change in power. Okay. And then in this P&L algorithm, we are taking the inputs as power and voltage. And we have taken this two put. One is for the power and this one for my voltage. Okay.
So we are taking this probe means we are changing from outside also. No, there is a probe.
No. Probe is for
No, sorry,
measuring.
displaying.
Yeah. Probe is for taking the output. So if we take a SCADA input or constant, then we are going to insert some value over there. Okay. Is it clear?
So we are inserting value from user, no? You mean?
No. If we are using any SCADA input block or constant like this over here, then we are inserting any value. Over here, we are just taking the measurement of this part. Okay, that's why I have written as PPV, means PV power. We are measuring. That's why we have taken a probe also here. to measure the output power.
Okay, sir.
We are not giving any parameters over here. Okay.
Yes, sir.
So up till
Sir,
yes.
sir, unit delay means P, if it is something like PT, the output from the product is PT, and then unit delay will create a delay of -1 or +1. It's like something?
Yeah. Yes.
Okay, sir.
So now we are on this part. We have taken the SR flip-flop and we are going to terminate this part. So I'll take a termination block. So for that, again, I'll go to sync. Yes. Here I'll get the termination. So I'll drag and drop this termination block and connect. Okay. And now I'll take a digital probe. So digital probe, I'll get it. Here is my digital probe. I'll connect it over here. And I'll rename this digital probe as enable underscore. Okay. So I have taken a termination block connected with this Q node, and this is my enable out. Okay. So now one thing is left over here. I need to take this signal and connect it to this boost converter, and then I need to provide the values for all the basic components which I have taken. Okay. So up till this part is done, everyone completed this part up till now.
Sir, their enable is signal from or signal go to.
It's from means we are sorry, it's go to actually not from.
Go to.
Means yeah, we're sending the signal. So here also go to, here also go to. Here we'll take the from block. Okay.
Okay, sir.
Okay, so now what I'll take two from block. So I'll take signal from 1 and 2. Okay. Now first I'll hide the name of both. Right click and hide name. And now I'll change the tag name as first as reference and second one as enable. Same scope. So I'll just check whether it is tagged out properly or not. So here you can see it's matched. Okay. Also over here, should check. It's matched. So up till now, is it done? Done? Any queries from anyone?
Yes, sir.
Okay. What about others? Is it done?
Yes, sir.
Yes, sir.
Okay. So now everything is done.
Yes, sir.
We have
Done, sir.
completed the model part. Now I'll just go to initialization and declare all the variables which I have defined. So first, let me define my TS. So TS would be equal to, I'll take it as 200 to the power minus 6. Next, I'll define my RL. So I'll just move in this way. So first I'll define TS, then RL. So RL would be equal to 0.1. And then my L or the inductor So inductor, I will take it as 3 e to the power minus 3. And then my ESR. So ESR would be equal to 0.001. And then capacitor. So capacitor would be equal to 810 e to the power minus 6. And then comes my R load and R discharge. So R load would be equal to 1000 and R discharge would be equal to 10. These are the parameters which was left. I've declared the variable inside it as RL, L, ESR, C, R load and R discharge. So that all I have declared over here.
Excuse me, sir.
Yes.
Sir, here you write the constant as 49 and 52 as the battery lower and battery upper limit. It is like similar to the mobile charging when we are at 20%, so the strength will be low, and when it will be more than 80%, it will be used. It will perform at high performance state. Is it
No,
like
no,
something?
no. It's not like something. See, first we are measuring the voltage across over here, and we are comparing it. We are just given a limit. Okay, so whenever it drops below 49, it will start. Means it will work on this boost converter would be enabled, and the voltage battery would be charging mode. Whenever it goes above 52, then it will disable it. Means it will give zero signal onto this queue, and it will disable this boost converter. Okay, so that's the main motto of this part.
So, sir, मतलब कि जब when it is disabled, so the boost converter is turned off, so the direct supply will be given to the output at the output voltage.
No. There is no supply to the output.
Okay, means directly battery provides supply to the output.
Yes.
Okay.
Sir, please explain again.
See, over here we have taken two comparator and we have set limits. One is 49 and other one is 52. So if you see the logic of SR flip-flop, okay. So if here we get the 1, okay, whenever let's take an example, we are measuring the V output voltage as 48, which is less than 49. So 49 minus 48 is 1 over here, and 52 is, we are also getting 0 over here. So here we're getting the as 1 as output. Okay. So if you take the truth table logic for SR flip-flop, then you will find that whenever it goes above 52, then from here we'll get the signal as 0, output as 0 from this queue. Okay. So that means on that part, this boost converter would be disabled. Means here we are giving the enable signal. So if it gives 0 over here, it will be disabled. So then it will not charge the battery. Means it will not supply the battery. Okay. At that point of time, this battery will supply to this R load and R discharge on registers over here. Okay. But when it drops below 49, then it will enable it and charge the battery at that point of time.
So means to say that boost converter is open circuit.
Yes, we are turning it on and off kind of thing.
Okay. So to when boost converter is on, only battery will supply the load.
When boost converter is on, then it will be
Sorry, sir. Off.
yeah, exactly. Okay. So is it clear till now?
Sir, but 49 and 52 cutoff, why?
It's just for understanding purpose. You can change the limit also. It's as per your requirement.
Okay, sir.
It's for making you understand that if you want to develop such kind of controller, then you can develop it in this way.
So it is like basically the case statement for the programming. So when it is above 52, so the system will be okay. What I was sorry, I just forget to ask about the 52 case. If it is 53, then this one is 1. So what will happen then? I just curious about this.
So how can we get 0 if we have 48, 48, 49 minus 48 is
Whenever
1?
we go above 52, we'll get 0 over here.
Okay.
Check once. Is it clear? Or still any confusion is there?
Yes, sir. Yes, sir.
Okay. Should I move forward? Should I compile this model?
Yes, sir.
Yes, sir.
So I have declared all the parameters, and now I'll click on OK.
So
And now
termination.
termination, we do not require this output from now. We just require this output of this Q
No,
part.
sir. In model initialization.
Okay, model initialization. I thought you
Yes.
said termination. Yeah. Note down the values. I'll just share it on the chat box too. Just keep it. And check also whether this from block is properly connected or not. So is it okay? Should I move forward? Should I compile this model?
Yes, sir.
Okay. So now we need to select this option, compile and load model in SCADA. So I'll just click onto it. It will ask me for save. So I just save it in the name MPPT underscore course underscore charge. Save it in any name as per your convenience. So let it get compiled. Okay, so compilation successful.
Sir,
Yes.
sir, it's showing an error.
What type of error?
Sir, it's saying that the component CMP underscore low can't inherit execution rate.
Okay. So let me just clear. CMP underscore row cannot inherit execution date. So here in the constant block, you have not defined as TS inside it. Check one second.
Yes, sir, I have not done that.
Okay. So for both this constant block, provide execution date as TS, and then compile and check.
Yes, sir, it's fine. Validation passed.
Okay. So any issues from anyone? Any errors coming out when you're compiling? Is it okay for everyone? Everyone model compiled?
Yes, sir.
Okay. So right now my model is also loaded. We are right now in HIL SCADA part. Here we'll find the various widgets already you have known about this. So as the name suggests, action means we can provide any action to our simulation using macro, button, text box. We can provide any parameters. We can change the parameters using combo box, checkbox, slider, knob. All you know, similarly as a name monitoring, we can use these widgets for monitoring purpose like capture and scope for seeing the waveforms. PE monitor we require right now for this model. Similarly, we'll find gauge digital display already you have seen through. For data logging purpose, you will find signal data logger and streaming data logger. So as the name suggests, streaming data logger, you can capture the data in .csv or HDFI format and stream it from one place to another using communication protocol. Similarly, signal data logger is used for logging the data in .cs format, and there are various formats you can use. Here you will find the connection widget as it's in a serial. It is required whenever you are connecting an external controller. So that external controller we can connect it using this serial probe. Okay. Next, you will find visual like group, subpanel, text node, image, etc. So that we'll see how to do that. Basically, it is used to improve your SCADA part. Now, yeah, here you'll find various flags like TSO, widget error, exception error, CIO error, SLD error, arithmetic overflow, DTV, TSU. This may come into your HIL Academy exam, so I'll just tell you all these things. So, okay. So basically, TSO error. If I talk about TSO error, it is means time slot overrun. The full form is time slot overrun. Means whatever the time step you have defined for your planned part. When you define the time step for the planned part, whenever you are selecting the new model part, and then at that point of time, you're selecting the time part. Okay. I'll just show you. Here, this is your TS for your planned part. We basically select auto. So whenever we select auto, it will choose the best suitable time step and compile the model. So this TS for your planned part. So whenever it exceeds the means whatever the time step we have given, and the model is beyond the time step for compiling it, it faces issues, then this TSO flag will pop up. Okay. Now, next is this widget error. WER means widget error. So whenever you make any issue, or whenever you do not write proper code for your SCADA widgets, like this SCADA widgets, then this widget error will pop up. I'll just click on create the panel. Now, next you will find SLD error or serial link status. It basically happens when you're connected with multiple number of real-time simulator, at that case, SLD. Okay. So whenever you're connected with 2 or 3 numbers of HIL device in parallel mode, and at that point of time you're running simulation, some device got disconnected. So this flag will rise. Okay. Now here you will find exception error and CIO error. So first we have seen the TSO error, means if the time slot exceeds over your given time duration for your planned part, then it will rise this TSO error. Similarly, we give a time step for our controller part, where we have given this is our time step for your controller part, this TS. Okay. So for this part, this controller blue part, okay, this is the time step. So whenever it exceeds, it will give this flag will rise, which is CIO error or computing interval overrun. Okay. This is exception error, means whenever there is an let's say some kind of error in your code, in your C code, or there is an error in calculation for your controller part, then this exception error will occur. Okay. So these are all this part. Now similarly, we have this arithmetic overflow. When there is any NaN value in your simulation, then this flag will pop up. Okay. Next is DTV, dead time violation error. This dead time violation occurs. Can anyone tell about dead time violation? Any idea regarding dead time violation? Anyone?
No, sir.
Dead time means system means some signal will require some time to start up even after getting the even after giving the input. So that is the
Okay,
dead
I'll just give a hint. What is the dead time for converters? Any idea?
It's turn off time.
Yes. See,
And between turn off time and turn on time, there is a dead time.
yes, exactly. That's a dead time. So, means in simulation, if you turn on 3 switches, means for a single phase inverter, there are 4 switches. So at same moment, if you turn on 3 switches at a particular time, then you will not find error in simulation. But when you're running that same model and you turn on the 3 switches at a particular time, then you will find this DTV violation error. So whenever you have developed a controller and that controller is violating this get time, then this error will pop up. This will pop up only in real time mode, not on simulation mode. I'll show you whenever I connect a model, whenever I connect to the real time simulator. Today I'm not connected, but tomorrow I'll show you that whenever I connect to real time simulator and I turn on 3 switches at a time for a single phase converter. I'm taking an example. Okay. So at that point of time, this JTV error will pop up. Okay. So that's the uh, function of it, this TTV error, this flag. Next is Psu fault or Psu error, means whenever our device get overheated, means when you put our device in kind of rack kind of system and there is no cooling system over there and it gets overheated, then this Psu will pop up. Okay. Next, this is the timer. It is the timing for your simulation, and here you will find the mode for your operation. So in Saturday, whenever I was connected with the real-time simulator, and I have run that model for electric vehicle, over there you have seen that it was written as real-time mode instead of virtual hill mode. Okay. Also, whenever I compile that model, that load model to virtual device option was not popped up. It directly loaded that model. Okay. So that's the difference. One was that load model to virtual device will not came. Next, this we can find the DTV error for our controller, and this will change to real-time mode. So now what we'll do, we'll just develop the SCADA. So first, I'll take a PE monitor.
Sir, I'm getting one error.
Yes, tell me.
Sir, that execution rate for VPV is means fail for the property execution rate of the component VPV. I have changed it to TS, but still it is giving the error.
This VPV TS you have defined over here, right?
Oh, yes, sir. Yes, sir.
Have you defined the TS over here with this model initialization?
Yes, sir.
Okay. Can you repeat the error once again?
Once again, sir.
Yeah.
Evaluation failed for the property execution underscore rate of a component VPV.
Okay. But if you have given TS over here in the signal processing and also you have defined the TS, then it will not give any error. But if still is getting error, then I'll just stop screen sharing. You can share it once and
Second, sir. I will save it again.
yeah, Mr. Krishna, tell me. Yes, you have raised a hand. Yeah, tell me what is your issue or what is your query?
Sir, my error is resolved.
Okay, okay. Okay, so we'll just develop the SCADA part. So first I'll take a group. One group I'm going to take for my PV. One group I'll take for my battery. And one group I'll take for power. Okay, that's it. So I'll just place it. I just enlarge it. Now I'll take a PV monitor first for my PV. Okay. And I'll take two slider to change my irradiation and temperature during running simulation. So I'll take two sliders. Now on the group 2, I'll take just a moment. Let me increase its size. And here I'll take one gauge for my battery voltage, one other gauge for my battery current, and one other gauge for, that's it for my battery. Okay, and now I'll use this group 2 over here and increase its size. Okay. I'll take this gauge and put it inside it as boost output, and this one as the gauge as discharge current. Okay. Now I'll take another group. This here I'll take one gauge for PV output power and another one gauge for output power. You can increase its size or decrease its size. And also I'll require a capture and scope. So I'll just drag and drop one capture and scope. Okay. And I'll take I don't require text display. So what I require a macro to initialize, and I'll require one digital display to see the SOC. I can take it or let it. I'll delete it. Not required. And let me take another group. In this group, I'm going to take a combo box for turning on and off the contactor. 1, 2 combo box. There are 2 contacts are there. So for the 2 contactors, I have taken 2 combo box, and I'll take 2 LED also for their status, whether they are turned on and off, and another LED for my enable or disable purpose. Okay. So do it up till now, and then we'll do the later onwards. I have taken 1, 2, 3, 4, and 5 groups. I have not changed the name or given any properties. I just drag and drop the widgets. Here I've taken PV monitor and 2 sliders. Here I have taken 1, 2 gauge. Also over here 2 gauges are there. And in this group I have taken 2 combo box and 1, 2, 3 LEDs. And here I have taken 2 gauge, 1 capture and scope, and 1 macro widget. That's it. So do this up till this part and let me know. Then we'll move to the next part. For any issues, please let me know. Or if you're done, please let me know. In group 1, we have taken one PV monitor and two slider. Group 2 gauges, group 3 also, group 4 also, and here we have taken two combo box and three LEDs. And here we have taken one caption scope and one macro widget.
Sir, done, sir.
Okay, so everyone completed. Should I move?
Yes, sir.
Okay. So first we'll just configure with basics, then we'll move to the advanced side. So we'll move in this way. Okay. So first we'll just double click onto this group and change the name, only the basic thing. So here I'll change the name for PV panel. I'll rename it as PV panel. That's it. Now next what I'll do, I'll just declare the PV monitor, what it will show. So I'll just double click, and here only thing I'll do is select the PV. That's it. So first I have renamed the group as PV panel, and then I have selected, double click onto it, selected PV over there, and click on OK. Okay. If you want me to repeat at any point of time, please let me know.
Sir, please repeat once again.
See, first what I have done, I have just double click onto this bar over here, change the name from group to PV panel. Okay. And then next, what I have done, I have just double click onto this PV monitor and change this, selected only PV over here, and click on OK. That's it. Okay. Is it clear to everyone?
Yes, sir.
Yes.
Yes,
O-
sir.
Okay. Now, next, what we'll
Sir,
do? Yes,
I'm unable to add that in group 1. How do you add?
you need to just drag and drop like
No,
this way.
sir, I know how to drag and drop, but I'm unable to drag and drop.
Uh,
Sir, this one is PV monitor is
yes, P motor is available over here now.
okay. Okay, so let me try once.
See. I'll just show you one demo. Just I have taken a group. Okay.
Yes, sir.
Now I'll just take drag and drop PV monitor and place it inside it like this way.
Okay.
Is it clear?
Yes, sir.
Try once and let me know.
Yes.
Okay. Now, second thing, what I'll do is I'll change the name for this group. Okay, so I'll double click and rename this group as battery. And then I'll rename this group over here as load. This one as battery, I've renamed it as battery. This one I have renamed it as load. And this one I have renamed as this one I have renamed it as power. Battery, load, and power. And here I'll rename it as contact. P panel, battery, power, load, and contact. Done up till now?
Yes, sir.
Okay.
So
Now, what I'll do, here I have done the settings. Now I'll do the settings for this part. So for this first gauge,
sir, for slider,
I'll do it. I told you now, first I'll move from the basic to the advanced. Okay. That's why I'll completing the basic one and then I'll go to the advanced one. Okay. So one by one, if I make it a complex at the same point of time, it will be very difficult for you. Okay. You will not miss the settings. Okay. You will miss the settings. So here for this gauge, I'll just change the name first. First, I'll change the name. I'll rename it as battery voltage. I've named it as battery voltage, and I'll select the signal as the signal as here. I have renamed it as battery voltage and signal as V out. Now, next, I need to go to this tab, widget settings, and then advanced settings. So I need to move to this advanced settings. So here, minimum would be 0 and maximum would be 60. And I'll click on. So I've renamed it as battery voltage, selected the analog signal as V out, and advanced settings, I have selected minimum as 0, maximum as 60. Okay. And I'll click on. If anyone wants to repeat, please let me know.
Sir,
Yes.
sir, in the battery settings, we have given SOC as 100% in the
Yes.
schematic editor.
Yes.
So when we run this, so it will start from 60 volts initially.
It will start from 60 volt initially. How is it possible? 48 volt we have declared, no? If you check the battery settings, 48 volt we have declared, no?
So then why we are taking its range to 60 volts?
We are just taking a assumption maximum as 60 volt, not a 60 volt as a default. Okay. So our meter would be start from 0 and maximum to 60. You can make it 100 or you can make it 1000 also. To make the gauge look proper, that's why we have selected the 60 over here. Okay,
sir, no problem.
Yeah. So similarly for this gauge, actually we are setting the limit for our gauge meter. That's it, nothing else. I'll just change the name as battery current. And signal as I out. So here I'll take as I battery. And in advanced settings, I'll take minimum as minus 10 to maximum as 10. And click on. So minimum is minus 10, maximum as 10, and signal as IBAT and battery current. Okay.
What's the maximum value?
Minus 10 to 10.
Okay.
Minimum is minus 10, maximum is 10. Okay. Similarly, for this load, I'll just double click for this gauge and change this gauge as name as boost output current. And signal as I out. Okay. And in advanced settings, I'll select the minimum as -10 and maximum as 10. And click on OK. We're not giving any values, we're just setting the limit for the gauge meter over here. Now, next thing what I'll do the settings
So
for this.
minimum and maximum value. will show
Minimum
up.
as for current, I have taken minimum as -10 and maximum as 10 for both this gauge. Okay.
Okay, sir.
Similarly, for this gauge over here, I'll just rename it as discharge current and select the signal I discharge. This one I discharge. Okay. And in advanced settings, same range as it is current. So -10 to +10. Done. Battery voltage, battery current for the battery section, for the load, boost output current, and discharge current. So here I have taken I discharge and here I have taken I out. Okay. So now I'll just configure the power over here, okay, for this gauge. So I'll just double click in the similar way and I'll change its name as PV power. And here I'll select the analog signal as PPV. PV power and P underscore PV, the analog signal. Okay. And in advanced settings, I'll change the maximum to 300 and click on OK. 0 to 300 I have selected over here. Similarly, onto this gauge, I'll rename it as output power and signal as P out, P underscore out, and in advanced settings, maximum limit as 300. So in this power gauges,
Sir, please show again output power.
yeah, first I'll just repeat once again. I'll repeat, no issues. So this PV power, I'll just taken this in basic settings. I renamed it as PV power and selected the settings P underscore PV. Okay. And in advanced settings, I have selected maximum as 300. Similarly, over here also I have selected the maximum as 300 for this output power. Renamed it as output power and selected the signal as P underscore out. Okay.
Okay, sir. Got it.
So is it done for everyone? Renaming, providing minimum, maximum, and selecting
Yes, yes, sir. Sorry, sir, to interrupt you.
Yes, yes.
I just have a simple query because I thought like PV cells are providing the power to charge the battery, and if the battery voltage is dropped below 5048, the boost converter is on, and it will again start charging the battery. So the level reach between 48 and 52. This is for only single battery. What happens if the batteries are connected in parallel or in some way, so that the batteries, one battery is charged to 51. So anything above 51, the boost converter is disabled for that battery, and
For
again
that purpose,
it
you
is
need to apply BMS.
pardon.
Actually, you need to design your controller and you need to apply BMS, battery management system. You need to apply onto that part. It's a kind of simple controller. It's a kind of design in a simple way that it happens in this way. But in that case, you need to design a separate controller for that, and you need to charge and discharge the battery. Here, what I have taken, I have not read the SOC of the battery. Okay, I've just turned on and off the boost. Okay,
Okay, okay. Okay,
so
sir.
okay.
Thank you, sir.
So in that case, what you need to do, you need to means detect the SOC of the battery, whether it is dropping below some point and whether it is going above some point, and then you need to means select a particular logic for it, and then you can implement. Okay.
Okay, sir.
So now I'll just move forward. I'll just select the PV. So for that, I'll just double click onto this macro, and here I'll just remove on timer. I'll remove on click, and I'll take on start and on stop, and change the name for this macro as initialization. I've renamed it as initialization. And now I'll go to edit in code editor, and I need to configure my PV because here I'm initializing for the PV. Okay. So I'll just here you can find in PV settings. Also, one thing I'll explain to you that after coming to this part, you'll find control commands, capture commands, and other commands. So control means if you want to control anything, you want to change the parameters. So you'll find all these options over here, like controlling your PV, controlling a contactor, which is there in the model. Okay. So whatever SCADA inputs was there, if SCADA input was there, then you'll find it over here in this control part. Else, if you want to capture any signal and you want to implement some kind of thing, then you will find the options over here. Else, in other commands, also you can capture, you can read any signals, you can read any analog signal, and you can read any digital signals, and you can implement any arithmetic logic also over here directly, and you can see the values. Okay. Like you want to change any power which is coming in megawatt into watt range or watt range into megawatt range, you want to represent it, that also you can do. You can multiply or you can divide as per your requirement. Okay. So right now we require this PV settings, and from here we'll load the settings. So I'll just click on load, and you can see this .ipvx file. So I hope you remember whenever I was demonstrating that waveform generator, from there in PV generator, you will whatever the file you are saving, it is saved in .ipvx format. So you can call over here this file. So I'll just select this type, third one, this one, Jinko JKM 300M 72 IPVX. So I'm going to select this one, provide illumination as 1000, press on enter, and then I'll slide it over here, provide temperature as 30 degrees. So this is my initial condition. Whenever I start simulation, this will be entered automatically. I do not need to provide the values. Okay. So I'll place the cursor on line number 8 and insert the code. Okay. You see this code is inserted over here. Illumination is 1000, temperature is 30. So is it clear up till now?
So, sir, this IPV file is already preloaded, means.
Yes, it is already there. So I've just called it from there. But if you want, that's why I demonstrated on the first part the function of waveform generator. Let's take an example. You want to you have some PV panel onto your rooftop, and you want to analyze in some kind of logic onto it. Okay. So in that case, what you can do, you will need to just take the data of the manufacturer. Okay, for that PV, particular PV, and you need to load all this data into waveform generator, generate the PV and IV curves, save that file in .ipvx format, and you can call it over here. Okay, that's the main motive or the main function of creating waveform generator and calling that file. Okay, is it clear?
So this IPV file is for particular solar panel. It will be different
Yes,
for different
yes,
panels.
yes, 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 exactly, exactly. It is different for different panels.
Okay, thank you, sir.
Yeah. So up till now, is it clear? Is it done?
Excuse me, sir.
Yes.
Sir, like I asked the previous query, which is out of the topic of the today's work or maybe this training. Can we have a simulation model for the VMS also?
Yes, we'll try. We'll try in Saturday. You should ask because we have miscellaneous session over there. So I think it's
Yes, yes.
better. You should note down all the queries like this, which is different from the topic, and then we can discuss that part in Saturday session. Okay.
Okay, okay, sir. Thank you, sir.
Yeah. So those who have any queries which is different from session wise, so we can discuss it on Saturday's session. Okay. So up till now, any issues from anyone, or should I repeat any part? Anything? Is it done from everyone?
Yes, sir.
Okay, so I have inserted this E panel type, and now what I'll do, I'll just save it from here. So it's now saved, and I'll close it. So it's done now. This part is done. Okay. Now we need to configure this slider. We need to configure this combo box, this LED that's remaining. Okay. So let's start with the slider part. So I'll just double click on slider, and I need to change the minimum and maximum part. Okay. So here you can see we have option only from 0 to 100, but for irradiation, we are to use a slider for changing my irradiation. Okay. So I'll make it as 10 minimum and maximum as 1200. You can make it as 2000 also. It's up to you. And step is 1, no issue. And I'll change the name as irradiation. That's it. And now I have given the limit, I have changed the name, but I have not given the instruction that what it should do, what it should change. So I'll just type over here HIL dot set underscore PV. Here you will find the session PV ambient parameters. So I'll just double click onto it, and it is inserted, and bracket open. I need to give the name. Here you can find the suggestion. I need to give the name for my PV. So for my name of PV is PV, and then comma. Then I need to give the illumination. So illumination would be equal to input value. Would be equal to input, and whenever you write input, it will give the suggestion. You have to click onto it and then close the bracket. So as we want to change the irradiation or illumination, that's why we need to write in this way that illumination equal to input value, because it's not fixed. Okay. So we have written hill.set underscore PV, then it will give you auto PV ambient parameters. We'll just double click onto it. Then bracket open, we need to type the PV name, whatever I have defined. If I have given over there as photovoltaic panel, we need to write in the same way. But there we have changed the name to PV. That's why I am declaring it as PV, comma, illumination equal to input value. Okay. Let's check code syntax. It's passed. So I'll click on edit in code editor, and I'll save this code and close. Is it clear? Is it done for everyone, or should I repeat or anything else? Please let me know. Is it done?
Done, sir.
Okay. So I
Sir,
just saved.
Sir,
Yes.
I have not saved the file in PV settings. That's why. So now what I have to do? Should I have
Yeah.
to sing from the recording and build that file?
No. That's not required. I have not saved that file also. Okay.
Okay.
It is already inside there over here. I just given you a demonstration that in case if you have any PV data and you want to use a particular PV panel type, then what is the process? Okay. But
Okay.
here I have taken an inbuilt IPVX file. I have not saved over there. Okay.
Okay, sir. Sir, how you have to load that file?
I told you now. See, I'll just save it 1 second. From here, if you double click onto PV, here you will get the option to load PV. And from here, wherever you have saved the file in .ipv format, you can load it directly. Okay.
Okay, sir.
Yeah. So any other queries from anyone? Is it sorted out, this slider?
Sir, is it written in the Python code? Because
Yes, it's written in Python code.
okay, sir.
But you will get the suggestion directly whenever you write. Okay.
Okay, sir.
So similarly, I'll double click on slider, and here I'll select minimum as 0 and maximum as 40. Okay, and step as 1. Now I'll change the name of the slider as temperature. Okay, and here what I'll write, hill dot set underscore PV, and you will get the suggestion ambient parameters. And similarly, I'll just keep the name as PV and comma. Previously, I have taken illumination, but I do not require illumination because I want to change the temperature over here. So I'll just type over here as temperature. Temperature equal to input value because I want to vary the temperature. And close it. So let me check syntax. Go to 18 code editor, save it, and close it. So in that case, I have used illumination, and illumination equal to input value, and in this case I have required temperature equal to input value. If I take illumination and temperature both over here, then both will change by changing this slider. So that's why we have taken two different sliders to change these parameters. Okay. Now I'll just quickly do one thing. Yes.
Sir, sir, please again show temperature coding.
Same. What I have done,
Okay.
I have just written temperature over here instead of illumination. Okay.
Okay, sir.
Same
Got it.
is there. Now, what I'll do, I'll just configure this capture and scope. So I'll just double click onto it, select the signals quickly. So I'll just require whatever the signals, just enlarge it a little bit. And first I want to see my VPV. I'll create VPV. Then I'll take IPV. And then I'll select voltage across the inductor. So I'll just remove this VL. Then I'll take output voltage V out and output current as I out. And then I'll take output of boost. So I out boost. I'll take it over here. And next I'll take battery, and then I'll take PPV and P out. P underscore V. And then I'll take P underscore. So let me configure this V port. I'll just enlarge it. You can see the in proper way that what are the signals I've selected. First I have taken VPV, then IPV, then VL, V out, I out boost, battery, PPV, and P out. So I'll take this PPV and IPV on first view port, VL on second view port, and V out and I out also on second view port. Okay. This I out boost and battery on third view port, and PPV and P out on fourth. You can take it on a single viewport also. That's not necessary that you should follow the same order. You can take it as per your own. Okay. So just select the signals and let me know if you're done.
Done, sir.
Okay, so I'll just close this part, and my capture and scope configuration is ready. So now I'll configure this combo box. So before doing that, let me just check whether my output is coming in not, because I have used this combo box to turn on and off this contactor. So I'll just double click over here. You can also control your contactor from here. So I'll just take it on software control, close this board contactor, and run the search. Okay, it's coming. I had just gone over here, contactors, take it on software control, make it on closed state both, and run the simulation.
Sir, contactor and close all this switch.
Yes, 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 yes. You need to close. Then you can vary the additional temperature. Is it okay? Is it coming? Okay. So should I configure this contactor? Is your output coming?
Sir, not as you're saying. I will check my issue later on.
Okay, so output is not coming, right?
Yes, sir.
So have you just turned means take it on software control and close the contactor and then you run the simulation? Have you done that?
Yes, sir.
But still no output is there. Is it?
Yes, sir.
Okay, okay. You
Something
just,
wrong with the schematic.
yeah, maybe.
Maybe.
So now I'll configure one LED and I'll configure one combo box. Rest you need to do it on your own. Okay. So I'll
Yes, sir.
just rename this name for this LED part. So this LED, okay, not required to rename. I'll just double click onto it. Select the signal. This one I was used for contactor load. So this is my signal, contactor load underscore FD. Okay. Here you can change the color. I'll change it on green and click on. So first I have taken it on contactor load underscore FD, and this is for my discharge. So this is my discharge underscore FD. And also I'll change the color to green and click on OK.
Sir,
Okay.
for PV, we just vary the slider and then we are getting the value, no? Means graph.
No, you can get the graph from the starting also without changing. But if you
Again,
change, you will get the values.
we are
Yes.
not loading that something. We are not loading, sir, there.
Here
We are
you are
directly.
given the settings that hill.set PV input file, illumination and temperature, which is default.
Okay, sir.
So now I'll configure this first combo box for my contactor load. This contactor, basically, if you go back to schematic, this contactor we are going to configure. So I'll just double click onto it and change the name as contactor load and select the case value as on and off. You already know this part. Okay. And what I'll do next, first I have changed the name as contactor load, then I have declared the two case, one is on and another one is off. And then here I need to change the name also. First case as on and second case as So I have configured it. Now here, if input value is equal to 1, do something when case 1 is selected or case 1 is on, and similarly for case 2. So I'll just select this part up to this hashtag and delete it. Similarly over here, I'll select this part up to this hashtag and delete it. Okay. Now I'll go to edit code editor and I need to control my contactor. So I'll go to this contactor settings. Just turn it off this PV settings. And here, first one is why I want to control my this contactor load. Okay. So I'll take it on software control. So for on case, it will be on closed. Okay. And this is my condition. If input value is equal to on or closed state, then just insert the code. So the code is inserted automatically. Similarly, for off case, it will be on open state, and I'll just place the cursor over here. Okay. Is it clear, or should I repeat?
Sir, can you show that PV model again? I'm not
Okay.
getting how to load.
This part, or you can load it from here. If you go to this PV, here you will find this option load PV. Select any of the file not it is required and provide the illumination as 1000. Enter, press and enter after loading it, and then here you can select the temperature also.
Okay, means any file we can load. Okay.
Yeah, any file you can load, but
Okay.
remember you just select this 1000 or temperature. If you are selecting these Jinko type files, okay.
Okay,
This
sir.
Jinko type files. But if you select any type of files from here, then it is already having the irradiation. Here it is 500 watts per meters irradiation is given and 50 degrees centigrade. Okay. So here you do not need to define, but in this case you need to define your irradiation and temperature. Okay.
Yes, sir.
So your homework is you need to configure this combo box for the discharge contactor. Okay. And this LED is for, I'll just configure it, enable out to see whether our push converter is on or off.
Sir, please show first and second LED.
Yeah. First LED is for this contactor underscore load FB. Okay. And this combo box I have used for contactor discharge. So here contactor discharge underscore. Okay.
Sir,
Yes.
when I press the run button, it is showing all sources have to be defined prior to start the simulation.
Okay. In that case, have you used this initialization?
Sorry, sir.
Have you used this widget initialization? Is there in your SCADA panel this widget initialization?
Yes. Macro.
Yes, macro part. Have you renamed it as initialization and done in this way, which I have done over here? Check once.
We have to rename as initialization and then.
And then you need to click onto this option on start and on stop. Rest it should be disabled. On click on timer should be disabled. Okay.
Okay, sir.
And then on start, you need to go to edit in code editor. Okay. Then you need to go to PV settings. Here you need to load the PV, provide the illumination as 1000, temperature as 30, and then place your cursor on line number 8 and insert the code. Okay.
Okay, sir.
Then you need to save it and then you need to run the model. Else what you can do, you can just go to this PV, you can load the file, provide the illumination and temperature and run. Try this now. Go to this model controls, PVs, load this file, provide illumination and temperature and run. Check whether you are getting the result or not.
Yes, sir.
Sir,
Getting some output.
Okay. Yes, tell me.
Sir, can you show the contactor edit code editor?
Yeah. See what I have done. First, if you take any combo box, then I'll just rename it as contactor load. Then I have defined the case value as on and off. Okay, and then
Yes,
I
sir.
have removed the case 1 as on and case 2 as off. Okay, then I have removed the hashtag part. Same here, same here. Then I have gone to edit in code editor, and in that case, as I want to configure this contactor, let me just zoom this part, then it will be clear for you. Okay, so this is my contactor load and I want to control it. So here I have taken the software control. First, on case it will be closed, so I have make it as closed and inserted the code over here on line number 9. Similarly, for off case it will be open, so I have placed a cursor onto this here and inserted the code directly. Okay, so in this way
Thank you, sir.
I have done this. Okay, so any queries from anyone? And your assignment would be to develop an same model using different kind of technique, which is PSO. Okay, so this model using, you need to change the controller, you need to do it on PSO optimization method.
So
You need to
combo
yes,
box one.
Perturb and observe.
sorry.
Sir,
This perturb and observe optimization technique. No? They
Yes,
have
we have
implemented.
done Perturb and Obserb today. You need to do with PSO, particle swarm optimization.
Okay, sir. Article song.
Yes, yes, yes. So any queries from anyone?
So can we see the graph of this charging and discharging in this model?
Yes, you need to use trace graph or any type of it, and you need to select the signals, and then you can do that. Okay.
sir, combo box one used for. So one.
This is for this load, contactor load.
Okay, sir.
Okay. So any queries?
सर combo box one नीचे वाला सर.
That I have not configured.
Okay, sir.
Okay. So that is your homework. You need to configure it. This is for
What?
your contactor discharge. You need to configure it.
Okay, sir.
Means actually we have configured this first combo box for this contactor load.
Yes, sir.
This I have taken the combo box, and you need to configure on your own. You need to test it, try it. Okay.
Okay, sir.
The same type you need to do it for that part, and then you just run the simulation. This is your homework, and assignment is you need to develop the same model using particle swarm optimization method. Okay. That's the assignment. You can submit it by Sunday. Not required that you need to submit it today. Okay.
Okay, sir.
Yeah. So any queries from anyone? Okay, so I think there is no such query. So that's all from my side. Thank you, everyone.
Thank you, sir.
Yeah.
Sir,
Thank
can
you,
you
sir.
make the assignment in the chat box so that we can save?
Okay, okay. I'll just type the assignment.